driver's license. Good. Can you imagine coming out of the parking lot and going at a constant speed the whole time? So let's say 30 miles an hour. You're just instantly 30 miles an hour in the parking lot and getting out. Can you imagine that? Or can you imagine accelerating the whole time? How fast would you be going by the time you get out of the parking lot? That's right. But if you didn't stop accelerating, you just keep going faster and faster, we'd never see you again. So if you think of the parking lot, you're speeding up, you're slowing down, you're going constant speed. There's a whole bunch of math functions going on. And so we like to, in math, be able to describe real life. So we use what we call a piecewise function. We can use an accelerating part for the first 2 seconds, decelerating part for 2 or 3 seconds, and then a constant speed of 4 to whatever seconds. And so the way that we would graph it is with a parenthesis like this. F of x equals parenthesis, and then we have 2 different things going on. The first thing we have going on is the function. This is the function. And then what's this annoying thing out here? What's that?
Domain.
That's the domain of when to use it. And then when you switch to use the next one. Okay? So, we're going to graph this. So I need your help. Take out your calculator. And I'm going to clear that. And I'm going to move this over to here. And, oh, thanks a lot, calculator. Okay, so what we're going to do is we're just going to graph x squared. So you push x and squared. And I think as soon as I get to the top, we're fine. When I graph it, it looks like this, x squared. If I go to y equal x, I'm going to go down 1 here, y equal x looks like this. Okay? So we can graph 2 of them simultaneously, no problem. But what if I didn't want this part, and I didn't want this part, and I only wanted that part? Could I graph that? And the answer is yes, you can on your calculator. And how many of you have done this before? You have. Not too many, though. Good. So what I'm going to do is have you go back to calculator, and we're going to clear everything. Clear and clear. And we're going to put in this x, except we're going to put it in parentheses because, oops, should be y equals though. Parentheses x. That's telling the calculator you're going to use the function x, and then you just go x is less than 0, 5. What's that? Yeah, I know. I did it fast on purpose to get you to think about it. You go, make sure your domain has parentheses, and then go second math. And then you'll see test. We're going to be using logic later, but right now we're just going to use test, and we're going to start with number 5. So when we graph it, you see a straight line, and then the calculator still defaults to y equals 0. But we'll fix that in a moment. Go to y equals, and then go to the end, and we're going to add x squared. So you go plus parenthesis x squared. Don't forget to go right arrow because you need to get off of that power. And then you're going to go parenthesis, and then it's going to be parenthesis x second test. We're going to go less than or greater than or equal to, which is number 4, 0. number 4 this time. And then, when you're done, who bent the graph?
With your parents.
Look at that. So, pretty awesome that you can do that. Now, we can change it. Do you want to change it? Do you want to straighten that thing out a little bit? Let's make this a little flatter. So to do that, we're going to go 0.5. Insert 0.5 and graph. And so now it's going to back off a little bit. It's going to bend a little at the beginning. And there you can see it's a little bit straighter. But you can manipulate it a bunch of different ways. Let's see, I think if you go 0.2, it's not going to look better. There, it's a little flatter. Looks a little bit straighter. Anyway, that's the graph. And you can add more if you want. We're going to do a lab where you're going to make a roller coaster, and you're going to get the roller coaster pieces to line up. And this is the calculator program that you're going to use for that. Yay. Next, how about a real thing? How many of you have ever shot off a model rocket? Have you? How big? Oh, that's big. My brother and I used to shoot these little ones, and if you're ever going to do that, don't spend a bunch of money on a real big one at first. Start with the little ones, right? Because it's so sad. He made a Star Wars one back in the late 70s. It was huge, and it had this big, I think it was Millennium Falcon on the side, and it had all kinds of stuff. You put the engines in, you had like 4 engines on it, and then you fire them up with a car battery, and it just exploded that whole thing, just like a Death Star. It was done. So what I'd recommend is get the little ones with one rocket engine, and then you light those. And did you guys ever have them go so high you couldn't see them? Yeah, it's incredible. So we're going to use a piecewise function. You know the piecewise function with the parenthesis, and there's 2 of these. And when you're looking at this, what do you think this 0 to 20 means with this function here? What does that 0 to 20 mean? What do you think that means? What do you think it means? The time. This is the time that you're using this. Now this is an upside down parabola that looks like that. And what do you think happens after 20 minutes or 20 seconds? What's the height? 0. So what happened to the rocket? It hit the ground, and so it's just laying there after t equal 20. Where will it be in 40 seconds? 100 seconds. It's going to be in the same spot. So at t equals 0, we're on the ground, and then this whole time between 0 and 20 seconds, that's where the action happens. Okay, so you're going to find h of 10 and h of 60, and see if you can find this. Give you a couple minutes. See if you can find h of 10 and h of 60, and then find the time where h of t equals 3075. Give you a chance. All right. So for this first one, where do you put the 10? The top or the bottom one?
The top.
Top, because this 10 is between 0 and 20, so you're going to use that top function. So then we're going to put the 10 in and then get -5, 10 squared, which is -500, plus 100 times 10, which is 1,000. 500 negative plus 1,000 is 500. So this is going to be equal to 500, I think it's feet off the ground. So it's going to be about here, 500 feet. By the way, is there another time that it'll be 500 feet? When it's going down. Want to guess when it is?
10 seconds be the highest? Its highest point?
I think it would, because 10 is right in the middle here. There isn't another time that it could be, so it must be here at the top. So I agree with that. Let's check. All right, so now, this h of 60 looks like you have to put that in, but if you did, you get like this big negative number. What's wrong?
It isn't.
It's more than 20, so you can't use the top one. The piecewise function says if this is 60, 60 is going to be on the bottom one. And 60 is always what height? 0, so done. Just laying there. Solve for h of t equals 375. Now, do we put 375 in for t? No, this is the height. This whole thing is 375. We set that equal to, does it make sense setting it equal to 0? No. It's somewhere up here, so here's 375. I think it's going to be in two places. We'll see if that works. At 375, it should be negative 5t squared plus 100t. Put everything on one side, and you get 5t squared minus 100t plus 375 equals 0. Divide everything by 5. What's 0 divided by 5? 0, so you'll get t squared minus 20t plus, what is that going to be, 75 equals 0. Was this factor? That would be so great if it did. That would be so great if it did. Here's a t, here's a t. Factors of 75, 25, and 3. Ooh, no. What do you think? What?
I forgot what that is. Negative 5.
So, thank you. So this is what I did, is I took this height and set it equal to that. I added this to this side, so both this and 375 are positive. Subtract 100 to get that. So always do that. Always keep me honest, because I'll make mistakes. Yeah?
Why do you have to divide everything by 5?
It's just going to be easier to factor.
Like you're just factoring in?
Yeah, and you could use your calculator to find this. But I think this 75 factors into what to give me 20? Anybody know? Five and 15. And both of these will be minus. You'll get negative 20, and you'll get 75. So the times...
Positive? Oh, never mind.
That's all right. 5 and 15. So if this was 10, this is 20, and this is 0. This is 5, and this is 15. Kind of makes sense, doesn't it? Works out. So notice again that this is very different than plugging in a 10.